Okay, everybody should be here. I'm starting the drawing. See, this is the, I told you already. So this is the complete details of the exercise. So first step was to make the 3D models that we made last class. Second, make the 3D assembly file. So this is right now I showed you. This is the 3D assembly. So now we have to make the drawing of the assembly. Okay, generate the assembly drawing of the belt tightener. Front view should be full section. Top and the regular right view should be the regular. Regular means the normal view. Okay, take care of the hatch line, the section lines in standard, and add the bill of material and the balloons. Okay, so we have to make the drawing. So open your A3 sheet. For example, this is my A3 sheet. So save the sheet with the some name. It's better save with the exercise number. So for example, the exercise number for this one is 14 point exercise 14.37. Okay. So save with that. That name will come automatically here. Okay. But now see one problem. See, in the drawing assembly will came because we want the job that it should move like this one. But if, for example, it is right now at this position, if I will make the drawing, it will come in this position. But for the drawing point of view, this position is not good. We cannot see the parts clearly. So for the drawing, I want it should be straight up. So again, same like we did in the already before, we can give some extra made so that the frame should be exactly vertical. The same made that we have given, if we want, because that way I did not deleted that one. So this is just, I have this called the suppress. So I can click that one, the frame of the whole assembly and the frame of the plane of the front plane of the whole assembly and the front plane of the frame. If I say them coincident, see this is the mate I am giving. This is the front plane of the frame and the front plane of the whole assembly. They are parallel with each other. So if I this extra frame, so what will extra mate, what will happen? So now it will not move. So now it's exactly vertical. So for drawing point of view, that position is good. Also, you can check from here, section view before putting in the, so now you can see in the section view, everything is clear, all the parts and this one. So that is the good for the drawing also. So now I will go to the drawing and I'll put the 3 views. So insert the 3 views, 3 standard views. See, it is very small. So I have to change what? Scale. Go to the properties. It is 1 to 5. This is very small, so I can change maybe 1 to 3 or 1 to 2. Let's try 1 to 2. Maybe 1 to 2 is very big. Okay, 1 to 2 I think is okay. Little bit move them up. Okay, so other steps are same. I told you whenever we say the drawing, no need to remind. All these steps that we use are same. This is the sheet I have given you already. The summary of the drawing, this one. So whenever we say the drawing, the other steps are same. Sheet should be A3 NSI. The standard we are following NSI. Title block, put all the information, line fonts, all this you have to check. And then insert the necessary view. So I basically started from here. These 3 steps you should do before. As I told you already, you can do these steps and you can save in the A3 sheet. So already I have saved these steps in the A3 sheet. So I have started basically from here, step number 5. I have insert the necessary views with the third angle projection with suitable scale. So this step right now I have done and I have inserted the 3 views. But if you want to just check before that one, so this should be the, from the document properties, this should be NSI. And this is the line font. So the visible line are 0.6, hidden line are 0.3. And this is the construction curve, which is center line is also 0.3 like this one. So this thing you have to do before that one. Okay, so now I have started from the step number 5, insert the necessary view. Number 6, remove the tangent edges. So the double lines due to the fillets, remove that one. Right click. remove the tangent edges. Okay, this one. So then what the next step? This is the next step. This is the online classes at the home. Just wait. Yes, this is the beauty of online classes. My children are making noise. Okay, so this is the three views are here. I have removed the tangent edges. Okay, next hidden lines. So in the assembly, I told you we don't put the hidden lines. Okay, this is our add the center lines. If you see some symmetry is there or some circle is there, you can add the center line. For example, here if you want, you can add the center mark. This is the center line and center mark. So for this circle, you can put the center mark. Okay. Okay, so next. Add suitable section view. So if it is not given, you have to decide yourself, but this exercise we have given you. So where is that one? The front view should be full section view, where the top and the right view should be regular view, the normal views. So front view should be full section, and in the section view, take care of the hash line. Hash line means the section lines. Okay. So this is the front view. I want this should be a section view. So where should be the cutting plane pass? Yes, Muhammad Al Hamama is with me. Yes, Muhammad Al Hamama. Ibrahim, Adnan Al Ibrahim.
Yes, top view.
Yes, either in the top view or in the front right view. Both can be there. I think the right view is more easy, so we can delete this one and go to the section view. This is the section view because it will be easy to click on the center, I think. Okay, it should be the section view and click in the middle. Here in the middle will be easy. After that, just check the direction of the section line. Okay. So yes, this is very important in the assembly. Which components you don't want to section? So what is our rule? Yes, Asim Al Sayyed. What is our rule? Which parts we should not section during the section view?
Yes.
So which parts we should not section in the section view? Remember?
Yes, the rib.
Rib is within the parts. We don't have the rib, but in the assembly, the complete parts, some complete part we don't want to section. The fasteners means nut, bolts, screws like this one. Okay, and keys also. And the shaft, if it is solid, our shaft is not solid, it is hollow, the hole is inside. So the shaft we will section, but at least, for example, this nut, this screw, and this key, because key is also fasteners. So these we do not want to section. So we don't want to section these three parts. So now we can select here during this step. When this window will come, exclude components. Components are rib in the feature. So which component we want? Three components down. Go here. Open this one. Open the assembly from here and three parts. For example, where is the nut? So first up, this key. We don't want this key to be section. We don't want this nut should be section, and even this pin is also like a screw. So this also we don't want to section. So select these three parts. The name will come here, and then say OK. After, just check the arrow direction. Arrow direction is OK or wrong?
Wrong. It should be opposite.
Wrong. It should be opposite. If it is if the view is here, then this should be opposite. To go here and flip direction. Okay, now it's okay. So put it here. So now you can check yourself. See the key is not sectioned. Okay, what else we selected? We selected what else? Key and nut. That is not sectioned. And this pin, CC pin also we selected only one. This we use by the mirror, so this should be also selected. Now how we can select this one? Again, only this key also if you want. Right click, where is this option? Somewhere in the properties. Yes, section scope. And now you can add more. So basically that we made by the mirror. This is the mirror component. Click this mirror component. This is the pin. So see now this pin also don't have the section line. Okay, for the remaining section view, whenever you see the two parts are touching each other, so change the direction of the one of them. For example, see this one. You can change the section line here. For this one, see these two are touching here, but the direction of the section line is different. So you can change for this one. Click here. So this is the section line. Okay. Here, if it is still you want to change, okay. For example, if you see this is one, if you want to change, okay. So if you change this one, here, both are also same. So either change the direction for the shaft also, if you want, you can change, but then this will become straight like this one. So it's okay. Otherwise, you can change what you can change the angle. If you are, for example, you want to change this one. So you can change apply. Okay, something like this one. You can change 30 degree or the something like this one. You remember this rule where we have studied this rule? This rule we studied in the section. So all the theory we are checking indirectly. Don't think that we are not checking the theory in the lab part. We are checking this one. What is this one? Section number? It was section view, chapter number 8. The last slide, this one. So when we say that this is the assembly, in the assembly section view, dot section, nut, bolt, screws, and if the material is different, then the pattern of the section line will be different. If the material is same, for example, so then we have to change. Either we have to change the angle of this one completely 90 degree, or we can change the angle like this one. Or even sometimes we can change the distance between section view just to show that this is a different part. Don't confuse that both are same part. So we can use something like this one. Okay, so that is the changing the direction of how we can change the direction, the angle of the section lines. Okay. Next. So up to the step number 10, it is same. Then for the assembly, this is the steps are this one different. So dot section, nut, bolt, screws already we have done. Change the direction of the section line already we have done. Now the remaining are this. Add the 3 dimension if needed. So no need to just leave it 3 dimension, only the overall width, overall depth, and overall height. It means the 3 dimension of the assembly. So if you want, you can add the 3 height of the assembly, the width of the assembly, and the depth of the assembly. No need. If it is given to you, or if you want interested, you can put. Otherwise, no problem in the assembly. Okay, so next is these two things. This is a special only in the assembly, the balloons and the bill of materials. So how to insert the balloons? So if you go here, so before starting the balloon, this balloon is here. But before going go here and design your balloon. Go to document properties and detailing. Not detailing, annotation, and this is balloon. Normally it is like this one, but always we prefer it should go here. Circular split line, and this is with the bent like this one. So here it is the item number, and here is the quantity. Both things will come here. Item number is here, quantity is here. If you want to change, there's other option. You want some other things, you can put also other things. But normally this is that we put the item number here, and this is the how much that item is used, the quantity of that one. So now we have to go one by one. We have 9 parts. Remember, we have the 9 parts. We can start from anywhere. Let's say from the beginning. Let's say from the bracket. Then this may be the pin. Then this is the frame. Then this is the shaft. So you can see that they're coming by number. How we put them by the in the assembly. Okay. So this is the okay, 1, 2, 3. What is remaining? Why it is 2? Okay, actually this is wrong. I put on the frame. This should be on the bracket. This should be on the bracket. And this is the bracket. Bracket is this one. So the bracket was the part number 1. Then the pin is part number 3. The order how we bring in the assembly. So we started from the bracket. We brought in the assembly first. So this is number 1. Then we brought the frame. So frame is number 2. Then we brought the pin. Pin is used 2 times. So the quantity is 2. So this is the pin like this one we have. So we have to put all the parts. So what are the remaining one? Then after this one pulley. So how many? 1, 2, 3, 4, 5. Then we have this key. Then we have this nut. Yes, what's remaining? 1, 2, 3, 4, 5, 6, 7. 2 remaining. Yes, which one is remaining? Yes, what is remaining?
Shaft.
Shaft. The shaft we have put. Shaft is number 4. This bushing, this small bushing. See this one, which is the thin inside. This one we can put from here maybe. Okay, so what is remaining? No, one thing is remaining. Washer, yes, this is the washer. If you cannot see, a little bit zoom that one. So this is the washer, this one. Okay, or we can put it here up to the. So now these are the 9 parts. So put all the 9. Last thing is just add the bill of materials. So go to the tables. This is the bill of material table. Select any view, so click on any view and just take the standard options. Just say OK. So it is attached with your mouse. This is the bill of material. You have to adjust a little bit maybe. Okay. Now go here and write the material of every part. First of all, change to this one to material. Material of every part is given. If you see here, starting from the part number 1, frame is CI, cast iron. Number 2 is the pulley, again CI, cast iron. Number 3 is, yes?
Should I change the each bracket to his or to their material?
Yes, we have to change like this one. We can go here one by one.
I mean in the part.
If you change in the part, then it should come here automatically. Sometimes it gives a problem, but it should come. If you assign the material in the part, then they will come in the table automatically. Okay. But if you did not assign there, no problem. You can assign here in the table. So whatever you like. So, but it should be there. So now the bracket is also CI, cast iron. Number 3, number 4 is what? What is number 4? Washer. Washer is phosphorus bronze. Okay, phosphorus bronze. Number 5, what is number 5? Shaft, cold rolled steel. Cold rolled steel. Number 6, pin, max steel. And what is number 7? Bushing. Bushing again phosphorus bronze. And similarly, what is the number 8? What is number 8? This is the woodruff key. Woodruff key material is not given. You can write, you can leave blank, no problem. And this, I think, the hexagonal nut also, the material is not given. So these 2 you can leave. The remaining materials you can put. Okay. So just put these materials here. When you write the material like here, for example, just click here he will ask you to break the link. Why break the link? If you are taking directly from the part and you assign in the part, it should come directly. Otherwise, if you want to write yourself, then break the link and then write whatever you want. For example, we want cast iron. Okay, similarly, just write the all materials. Okay, that's all. So then your drawing will be complete. That's all your drawing is here. So just save that one. Title block. The name is this one, the belt tightener. The name of this is belt. Okay. Belt tightener, the name, material no need to write here, that's all. Even this one, this is not need. Little bit move it up. Okay, so this is the assembly drawing is complete. You can rebuild that one. Okay. Okay, so that is the drawing of the assembly. So this was the step number 3, generate the assembly drawing of the belt tightener. Okay. Now remaining 2, 4 and the 5. This is the drawing for the frame and this is the drawing for the pulley. So both are basically the review of the section view. Just I want to show the different type of section view and all these things. So see, this is very important. First of all, the drawing of the frame. Okay, so this you can make, save this one, save with some name, that's all. Okay, now open even the assembly, there's no need now. If you just keep it, because if the more files are open, it becomes slow, the computer becomes slow, so we can close this one also. So now we want to just make the drawing of the frame. So just first open A3 sheet. Where is my A3 sheet? So now I have to make the drawing of the frame. So go to the view, insert the frame. So this is the 3 view of the frame. If you want, here you can put the model view also. This is the model view if you want. You can put that one. Okay. So other things are same, just remove the section, the tangent line. But in the, now it is the drawing of a part. So all the rules of the part. Hidden lines should be there. In the part, it should be there. Assembly we don't need, but in the parts we need the select the view. Okay. What we want, this is the. So this is the section view. We want the removed section view to show the elliptical column, and we want a revolved section view to show the beam cross section. Okay, and then the detail view. So what is the removed cross section view? Anybody remembers? The same in the section view. This is a review of the section view also. So this was the removed section view. That we put any section view. For example, this is the right section view, but not its standard position. So this is the cutting plane passing through here. This is the right section view here, but we're not putting here. We're putting here. That is called the remove section view. Just remove any view from the standard position. It can be a full, it can be a partial. So in this case, he's asking a partial view. Basically, he's asking the removed section view to show the cross section of elliptical column. He want to show that this is the like a ellipse. This thing we want to show. Okay. So what we will do in this case, just go to the sketch. If you are interested in small area, just go and draw a simple line in that area. So we are interested only in this area, just to show that is the ellipse. You just draw a small line here. After that one, select this line and go to the section view. So now you have the section view of this area only, but also the background is coming. We're not interested in the background. So just go here and click on the slice section. So it will now like a slice, simple slice from here. So put it here. So right now, if you say, you can say this is a partial top view like this one, because it is aligned. It will can move only up and down, aligned with the main view.
Doctor, can you do it again, because the video cut and I didn't see it.
Okay. What we want to do, we want to show that this area is like an ellipse. The section view of only this area. We are interested on only that one. So go to the simple sketch and draw one line of the area that you are interested, that you want to cut to show the cross section at that position. Draw a simple line there. Okay. After that one, select that line and go to the section view. Click on the section view. So now it is the section view of that area, but the background is also coming. We're not interested in the background. So go here and click here, slice section. This one, slice section, partial section, and then slice section. Okay, so now if you put it here, so this will be and you can see the partial section view at the top. But see, it is aligned. It can move only up and down. Here is asking make this one as a removed section view. So removed section view, it should be free. We can put anywhere. So how to make the removed section view? Just select the view and right click. And this is the break alignment. This is the alignment, break the alignment. After the breaking the alignment, now it is free. Now it can go anywhere. So if you try to move this one, now it can go anywhere. So just put it maybe close to that section view if you want. So just show that. So anywhere that you like, you can put that one. So now this is a removed section view. So this was this step, add remove section view to show the cross section of the elliptical column. So this was the elliptical column. So this was the elliptical column and we have shown the cross section here. Next, add revolve section view to show the beam cross section. This is the beam, the middle area this is the beam basically, this one. So we want to show again the cross section of this area, but now as a revolve section. So it is also same. So this is the revolve section means. So we want to show the cross section of this one. So same step, go to the sketch. We are interested to show the cross section of this. I think just click here, draw one line here, same thing. Same, select this line, go to the section view. And now this time again the background is coming. So just go here and slice section. This is the slice section. So now if I put it here, it will be like a partial right view, partial right section view. But we want to show as a revolve section. What was the revolve section if you remember? This was the revolve section. That we want to show the cross section at any point. So for example, the cross section at here is like a square. Cross section at this point is like a hexagonal. Cross section is like, so we want to show the cross section. So just we draw the view here. If you see here. So this is the here. So for example, what is the cross section here? We just draw the cross section here like this one. So if I move this section view from here and just bring to the top view. Okay. So no, for the front view, it will become a revolve section. Okay. So we can put like this one if you want. Otherwise, we can put with the break line. So how we put with the break line? This is the break line. So this is the break line. He's asking select any view, so select this view. Okay, now this is the break line. Put the break line. Okay, then you can increase the distance. Okay, and now if you bring here, So this will be revolve section with the break line, same like this one. Same, this is the revolve section, and this is the revolve section with the break line. Same like this one. Okay. Okay, next. Next, add the detail view to zoom the keyway. So sometime we want to trusted some area, like we want to do the small things, we want to zoom that one. So for example, see here. So this is the keyway, small keyway, but we want to give the dimension and other thing in a zoom view, so we can go there. So this is the detail view. Detail view is something like the zoom. So if you click here, so he will ask you the draw a sketch around the area that you are interested. It comes with the circle, but you can do it with circle or with any sketch. So this is the detail view, and make small circle in that area. This area we are interested, only this, and where is the keyway is there. Okay, so now it is attached with your mouse. It is there. It is zoomed. The scale is different, 1:1. If you want, you can make more bigger, but this is 1:1 right now scale. So this is called the detail view. So basically, we have this area we have made interest zoom, and this is here detail view. Okay, so like we have zoomed this area to as a separate view. So this is sometime we need for the small slots or small holes. Sometime we use this one. The scale of the whole drawing is 1:2, but this is bigger, 1:1, almost double that that one. Okay, show all the dimensions. So just put all the dimensions. In this case, you have to put all the dimensions. What we simply count. So all the dimensions of this frame, whatever this 1, 2, 3, 4, 5, all the 6, 7, this 10, 11 dimension, you have to put all the dimension as given to you. But main thing is the last. This is the last thing here. What is? Yes, this we do the review for the section view, and now we are going to the review for this tolerance. Apply the tolerance as given in the bottom note of the exercise. These fitting dimensions should be shown in the limit size. Okay, 3 decimal places. So he's asking that give the tolerance as given in the bottom of the exercise. So the bottom of the exercise. So this is the new thing. Normally, so we want at the end of the semester you should be a professional mechanical engineer. So see, this is the instruction given at the bottom. What are the instructions? Draw the assembly, assume it is the parts, use the tables for the limits. Okay, this is the instructions for the tolerance. For example, he's saying the bushing fits in the pulley with the locational interference fit. Shaft fit in the bushing, free running fit. So where the parts are fitting together, all these fits are given. Okay, so what is this fit? So what is the meaning of this one? This is our tolerance chapter. If you go to this tolerance chapter, again, if we go to the tolerance chapter, this is the table. Again, we have used in the tolerance chapter. Yes, what was the tolerance chapter? Tolerance, this is the tolerance chapter number 11, 12. So all the theory basically we are applying in the practically in the SolidWorks. So if you remember, we solved some problems by using the sheets at the end of your book. So we use this one and many other sheets. So this is the table 12.4, table 12.4, and basically in our book it is which page? So we use the table at the end of the book, which was this table we have used. So in that exercise, but the important one they have put separately in one page. So this is a table that is given in the slide. This is a table. These are called the preferred fits. So normally these are the very the common fits that we are using. So by using this table 12.4, so we will solve this one. So now first thing for the, because we are making the drawing of the frame. So in the drawing of the frame, so this is the diameter of the, for example, the hole, this diameter of the hole. So what's the dimension for this hole? So dimension of this hole is 16. Okay. But which part will fit here? Let's see the drawing. Which part will fit in this hole? Yes, who is with me? Abdul Aziz Al Dajani. In this hole, which part is going to fit?
Yes, Doctor.
Which part will fit here in this hole of the frame? See our assembly, what we have to fit here? This pin. Okay, so pin is because the diameter of this hole is 16 and the diameter of the pin here is 16. So actually when we made the assembly, so this pin went here. So basically the both have the same size, 16. So but which type of the fit we want? So this is pin and the frame. See, go down here. Where is pin and frame? This one, D. Pin fits in the frame, free running fit. Pin fits in the frame, free running fit. Okay. So now go to this table. So free running fit. What is free running fit? This is free running fit. Okay. So now we have two options: hole basis or shaft basis. If nothing is given, by default always hole basis. Okay. So now the free running fit, our fit is H9D9. Okay. So H, the capital letter is for the hole and the small letter is for the shaft. Okay. So in the frame there is a hole. So it means the H9 is for the frame because the hole is in the frame. So H9 is for the frame. So now we'll go to the frame. So we will select the 16 and now we'll go to the tolerance, fit with the tolerance. And now we will select this one. This is hole. So this is hole. Go to this one, H9, capital H9. H9. This is H9. Okay. And then 3 decimal places. He said 3 decimal places. Go down and change it to 3 decimal places. Okay, that's all. So first take the values. This is the 0.043. After that one, go again and now change it to the limit size. Okay. So now this is the basically the win. This is the dimension for the free running fit. This should be the dimension. This should be the tolerance. So this should be the tolerance for this one. Okay. So similarly, what are the other parts is fitting in the frame? So this is the frame. What other part is fitting in the frame? Yes, anybody quickly. Mutib al-Jabr. Which part is fitting in the frame? Mutib al-Jabr?
Yes, Doctor, the shaft.
Shaft. So okay, so shaft is going to this top hole. So go down. Where is shaft? This is C. Shaft fits in the frame. Sliding fit. Okay. Sliding. This is sliding fit. So shaft fit in this again hole basis H7 G7. So again the frame has the hole. So for the hole is the capital letter. So H7. So H7 is for there. So we will go to this is the hole. We can put it here. Okay, so H7, go to here, fit with the tolerance. It is hole, go to hole and select H7. H7, 3 decimal places. Okay, just first say OK, and second time again click and change to the limit. Okay. So this is the tolerance. So these holes. So that was our step number. So this was the applied tolerance given in the bottom of it. So that's all. The second step number 4 is completed. Yes. Other thing you will do yourself, the simple remaining dimension you will put and complete the the title block, the name, and other things. Just complete yourself. Okay, save this one. This is a drawing of a frame. You can put the drawing of a frame. Oh, this should be saved as, I saved in my A3 sheet. No, it should be saved as frame. Okay, something. So anyhow, you can put it down. Okay. So that is. So now again open A3 sheet. Where is the A3 sheet? A3. Yes, this is, I have saved with this one. I can delete that one, no problem. I saved in my A3 sheet. So open your A3 sheet and after that immediately save it with a new name. So for example, this is the, now the last drawing is for the pulley, so save as for the pulley. Okay, so see, this is the pulley. So what is for the pulley? Make the detailed drawing of the part number 2, the pulley. Show the right view as a regular view and front view as the upper half section. So only you have to show 2 views because the symmetrical part, so only the right view and the front view. 2 views are sufficient. So, but the right view is the normal one, and the front view we want the upper half section. Add the dimension and put the tolerance. Okay. So go here, and this is the 3 views. Go here, select the pulley. This is the pulley. So 2 views, only 2 are sufficient. No need, because you see the top and they are both are same, so no need for the top view. So just put these 2 views that are sufficient. If you want, you can put the model view. Okay, other steps are same, just remove the tangent edges. Put the hidden lines. Okay, and all the dimensions fully, I think very less dimension, only few diameters are there, but you have to put all the dimensions. Part, you have to put all the dimensions. So for example, pulley, this one, 1, 2, 3, 4, 5, 6, 7, 9 or 10 dimensions, put all the dimensions. But only we are interested, first of all, the section view. He's asking the front view should be half section. Okay, so how to draw the half section? Remember, this was our half section. So in the half section, basically used for the symmetric parts, we remove the half, basically the quarter portion from here, and from the front is the half section. So the half of the view will be section, half without section, and we don't put the section on here. So it is for the symmetric part, just to compare the both, how it is from the inside, how it looks from the outside. This is the half section. So same thing we will do for the pulley here. So we want the front view as a half section. So where is the half section? Go here, and this is half section. So now we are seeing from the right side. So there are 2 options. Do you want to see the lower or the upper one? So he wants the upper one as a half section, this one. So click this one and put it here, click here. So that is the basically, first delete this one, the normal, no need for the normal one. So put this one as a, okay. See here, again I will put, just to remind you. So go to the section view. Where is section view? Select, this is the half section, and in the, because we are seeing from the right view, so in the right view, if you're seeing, see the arrow direction, there are 2 options, this or this. You want to remove the top portion and section, or you want the bottom one. It is given the upper portion, so this quarter that we want to see, this quarter one. So click here, bring in the middle, and now you can see the top view, upper portion is half section. Okay, so that is upper is half section. And the last thing, add all the dimension. You can put your all the dimensions. And this is the last. Apply the tolerance as given in the bottom of the exercise. So what is the? So for this one, pulley, which parts is fitting? Which part is fitting inside the pulley?
Pushing.
Yes, bushing. This bushing, you can check from the size. The inside of the pulley is 26.9 and the outside of the bushing is 26.9. So these two same size, they will fit together. So the bushing will go inside the pulley. So what is the fit for the bushing? Yes, who will tell me just quickly? Who just see here? Saud Al-Qahtani is with me. Which type of the fitting between the bushing and the pulley? Which is the fitting? Bushing and pulley. This one, A. Bushing fits in the pulley, locational interference fit. Locational interference fit. So go to this table. Locational interference. What is the locational? This is locational clearance. This is locational interference. This is locational interference. So for the hole, again H7. So because this is the hole for the pulley, H7, capital letter H7. So go this one. Just go to dimensions. This is for the inside diameter. So this is the inside diameter. You can put it here. Then go to the fit with the tolerance. No, sorry. Fit with the tolerance. Select the hole and select the H7. Three decimals. Okay. So first this is the value. The values are here. Okay. Now select this again and now make it to limit. So this is the value for this tolerance for this diameter. Others you can put the other dimensions are simple. Just put the other dimension, put the complete the title block, the name is pulley, drawing number you can put 40. Material is also given. For the pulley material is I think cast iron. Quantity is 1. Tolerance is not given. If it's not given, there's no need for the so but at least the material should be there. Material is cast iron, quantity is 1 and the name should be there. Okay, so that's all. Make a folder, save all your parts, files, everything in one folder and submit the folder on the Blackboard. Okay, so I'm making the link plus I'm putting this file on the Blackboard and then you have to submit. I'm starting the recording. So then you can put all these parts. That's all for today.